Hi Year 5, welcome to Thursday's maths lesson, and this is going to be our last lesson on line graphs, and we're going to be looking today at interpreting line graphs again. So start with the review task, have a look at the question and see how you get on. Okay, so you might recognise this line graph from yesterday. It's a graph to show Sam's heart rate during exercise, but it does say that more than one person was exercising with Sam. And the question is it possible to show the other people's heart rates on the same line graph? So as well as Sam's heart rate in our table now, we've got Hannah's heart rate and we've got Charlie's heart rate. Now you might think, okay, I need to maybe draw a different line graph for each person. But actually, because lines can cross over each other in the way that bars can't so easily, we can actually show more than one piece of data on the same line graph, which is quite amazing. So I'm going to just kind of show you how we might do that. I won't do all of the data because that will take too long. But if I just sort of demonstrate to you how this would work, you might have plotted the points as well, so you can see if you've got the same as me. So we've got Hannah's heart rate. I might put Hannah in pink because then we can see the line being different to Sam's. So if I highlight Hannah in pink, and just make sure I've got pink ready. Okay, so the first time that Hannah recorded our heart rate was at the beginning, 0 minutes, and it was 62. So I need to use my scale to find 62, and I know 62 would be about there because the scale is counting up in tens each time. So I know that I'm going to have all the numbers between 60 and 70 in between that space, so I can estimate, can't I? 5 minutes, it was 68, so I'll go to 5 minutes and plot the point 68, which is probably about there. 10 minutes was 100, so again, I'll plot my point accurately, and then we've got 110 at 15 minutes. So actually, we're now overlapping Sam's line, and then the next one overlaps Sam's line as well, and we've got 105. So I won't go any further than that, but just so you can see, I'm going to join the lines up. Oh, sorry, using the wrong one. Okay, there we go. And so now you can see that we've got Sam's information clearly, but we're also starting to see Hannah's line as well. So you probably had something that looked a little bit like this when you drew your information on. I put Charlie's heart rate in green, so we can see quite similar heart rates, all of them going up, increasing, and then staying about level and then decreasing. And that's what happens when you exercise. Now, there is one thing I would say about this graph, because actually the lines are quite squished together, aren't they? So how would you get the data to be more spread out, but still be able to plot the same points? Well, what we could do is, because this data doesn't actually start from 0, there are no heart rates that are actually 0. You know, the lowest one is actually 62. We could maybe have drawn our graph with the scale starting at 50, and then we could have used more squares between each of our scale, counting up in 10, and then we would have been able to space out those lines a bit more, and that might have been a bit easier to read. Just something to think about for the future. Okay, let's carry on with our lesson. So now I'm showing you a new table of information, and we're going to explore some line graphs with this. So pause the video and have a read of the question. Okay, so the information in the table shows the number of flights departing from 3 terminals at a certain airport on Friday evening. So we've got 3 terminals, and I can see the 3 terminals here in this column. And then we've got the times that those flights depart, and we've got different numbers of flights departing from each terminal at different times. So quite a lot of information there. What can we say about the number of flights departing from this airport on the Friday evening? Well, it's a bit complicated to sort of draw any conclusions because we've got all these different numbers. I could tell you that the number of flights departing from the airport was different at each terminal and different at each times. I can't really see any where they are exactly the same. Oh, maybe there. So the number of flights departing from terminal 1 and 2 was the same at 9 o'clock at night. It's hard to draw conclusions, isn't it? What if I go to the next page? So now I'm showing you a line graph of that information. So have a look at this question. Is it easier to answer this question when looking at the lines on the line graph or the table? Pause the video and have a think about that. Okay, so looking at the lines, I can draw a lot more conclusions just by instantly looking at those lines about the flights leaving from the different terminals. I can see that Terminal 2 had the most flights because I can see the number of flights departing on the y-axis, and Terminal 2 has got the highest dots. I can see that, what else can I see? I can see that Terminal 3 had maybe the most up and down changes in the number of flights departing, the most variation. I can see that Terminal 1 started with the least flights, but then the number of flights increased and then it decreased. So I can actually use the line graph to say a lot more about what was happening with those flights. And that's why we use line graphs, because we can draw conclusions just by looking at the lines very quickly. So now we're going to look at some questions to do with interpreting the line graph that has more than one line on it. So this is a bit new, a bit different from when we were interpreting on Tuesday. So first we're going to start with some questions that are just about interpreting the line graph. So pause the video and have a read of those questions. Okay, so the first question says, when was the largest number of flights and which terminal did they depart from? So actually, we've kind of already answered this question, haven't we? We've got the number of flights departing on our y-axis, but we want to know when was the largest number of flights. So I can see that the highest dot with the greatest number of flights departing is this one, and it's Terminal 2. And I can see that it's going to meet up with this time on our x-axis, which is 18:30. So that's 6:30 p.m., isn't it? 6:30 p.m. And I can see which terminal they departed from because it's a blue line with the squares on for each dot instead of the triangles and the circles. And Terminal 2 is the label next to that line, so I know it was Terminal 2. Okay, let's go to the next question. It says, when was the largest number of flights departing from Terminal 1? So this time I might want to highlight, and you could do this as well with pencil, just, draw over the line. I know I'm looking at Terminal 1, so I'm going to look at the green line because that's got the label next to it. So when was the largest number of flights? Well, it starts off at a low number of flights and then it increases, and that is the highest point. So I need to read along. Yeah, that is the highest number that we've got there. And I need to read down to my x-axis to see when was the largest number of flights. So it's 20:30, and I know that that is 8:30 p.m. Now you might be thinking, oh, but what about this time? Now you can see that actually along the x-axis, the time increases equally. We've got a scale going up of half an hour each time, haven't we? 6:30 to 7, and then 7:30, and then 8, and then 8:30, and then 9. And so we've got all the times in between there as well. So this point here says 8:30 till 8:59. So it runs from about here. 8:59 would be just before 9 o'clock, which will bring us to the next point. So hopefully that makes sense. So at this actual point, it would be 8:30 because each of these points is written at a half an hour interval. Hopefully that makes sense. So when was the largest number of flights departing from Terminal 1? It was 8:30 p.m. Okay, at what time did the number of flights departing from Terminal 1 start to decrease? So again, I'd need to look at my Terminal 1. I could highlight the line increasing, and then I could look at when it starts to decrease, and it's this point, and we've just labelled that point, haven't we? So it's the same time as the question before, it's 8:30 p.m. So just copy that down there. Okay, looking at the next questions, when we're looking at more than one piece of information on a line graph, we can do some comparison problems. So have a read of the questions on this page, pause the video. Okay, so question 1 says, how did the number of flights departing from Terminal 3 change between 6:30 p.m. and 8:30 p.m? So we're comparing what was happening with the flights between these times, this time duration. So I can find the 6:30 and I can find the 8:30 as well, which is here. So we're looking at the number of flights departing from Terminal 3 and how they changed during those times. So what I'm going to do is look at Terminal 3, which is the orange line with the triangles. So I can see that the number of flights decreased first and then increased and then decreased again. So that is how the number of flights departing from Terminal 3 changed. They decreased, then increased again, then decreased. The next question says, compare what was happening to the number of flights at Terminal 1 and Terminal 2 between 6:30 and 7:30. It's the next hour on, isn't it? So I'm just going to clear my annotations so we can look at this again. So I'm going to find the 6:30 and the 7:30. There it is, 6:30 and 7:30 this time. And I'm looking at what is happening to Terminal 1 flights and Terminal 2 flights between those times. So I'll look at Terminal 1 flights first. I'll highlight that in green because it is green with the circles. So Terminal 1 flights were increasing between that time, and Terminal 2 flights were decreasing. Okay, super. Now, looking at the next set of questions, you can also solve difference problems between two different sets of data that are being shown on the line graph. So pause the video and have a look at the questions below. Okay, so when we're looking at finding the difference, we've been doing quite a bit of finding the difference. We want to either use our subtracting methods, starting with the larger number and subtracting, or we want to count on from the smaller number. We want to find the bit that's sort of in between the two numbers that we're looking at. So question 1 says, at what time was there the greatest difference in the number of flights departing from Terminal 1 and Terminal 2? So I need to find the greatest difference in the number of flights departing Terminal 1 and Terminal 2. So let's look at Terminal 1. There's Terminal 1, I'm just going to highlight it. Let's look at Terminal 2. I'm going to highlight that one as well, it's the blue line. Now, where is the difference between those lines at its greatest point? It's not here, is it? It's the same there, gets a bit greater here, smaller, and then a little bit bigger, a little bit bigger. It's here, isn't it? This is the greatest difference. And actually, if I look at the numbers, I can see that Terminal 1 has 2 flights departing at this point, and Terminal 2 has got, that must be 11 flights departing at this point, because I can see that the scale is counting up in 2s, and so each line in between must be the odd number that comes in between each even number. So at what time was there the greatest difference in the number of flights? Looking at the time when those points were, it was 6:30, so that would be the answer. Now it says here, what was the greatest difference in the number of flights? So I'm just going to use a dotted line to sort of show you the difference, just to make it really clear. So I'm going for the difference between this number of flights and this number of flights. So it's the difference between 11 and 2. So I could do 11, take away 2, to find out what the difference is. Or I could start at 2, and I could think, okay, what do I need to add in order to get to 11? And that will help me work out, you know, what is between 2 and 11. So 11 take away 2, I know that really easily. It's 9, because we've got an odd number, we're taking away an even number, so that's got to leave us with another odd number. Okay, so the greatest difference in the number of flights was 9. What's the difference in the number of flights departing from Terminal 2 and Terminal 3 at 7 p.m? So this time we're given a time. I'm going to look at that time on the graph. It's 7 p.m, so that's 1900 hours. And it says, what's the difference in the number of flights departing from Terminal 2 and Terminal 3? So I need the Terminal 2 point, which is there, and I need the Terminal 3 point this time, which is there. That was the orange line, wasn't it? So I'll use my dotted line again to draw the difference. It's the difference from this point to this point. That just moves some of my previous information. Ooh. There we go. Hopefully that makes sense. So we've got 7 o'clock, we've got 2 points. So now I need to look at what those points are. So we've got 9 there, and we've got 0 here. So the difference between 0 and 9 is 9. That's another nice easy one. And actually, if I move those lines and put them over the top of each other, they should be the same, shouldn't they? Okay. Super. So difference in the number of flights is 9. Okay. The difference in the number of flights departing from Terminal 1 and Terminal 2 was often 2. At which times was there a difference of 2 flights? So I'm just going to remove my annotations from here because I want to look at Terminal 1 and Terminal 2 again. So I'm going to just highlight Terminal 1 and Terminal 2 so you can see it really clearly. highlight those points. There we go. Now, when was the difference? 2. That's what I need to be looking at. So I'm just going to use my dotted line again. So I know that the difference isn't 2 here, it was 9. It's not 2 here. If I look at my scale, then I'm looking for points that are perhaps on each line, because the difference here is 2 each time, isn't it, the scale? Or I could look at where we've got an odd number and then the next odd number. So I know that that gap goes beyond the lines. Oh, but looking here, I've got the difference here is between 6 and 8, so that's 2. That's slightly wider. This is the same, the points are at the same place here. And I've got another difference of 2 there, between 4 and 2, and then I've got another difference of 2 here. Because if I look across, that's at the odd number, it's 3. And then if I go down here, this is at the odd number 1. The difference between 3 and 1 is 2. So let's look at those times. We've got 8 o'clock, we've got 9:30, and we've got 10. So those are the 3 times. Okay, now you've got a guided practice task, so pause the video and have a go at those questions. Okay, so this graph shows the number of hot chocolates and ice creams that were sold in a cafe as the temperatures rose. And hopefully you've noticed that as the temperature increases on our x-axis, the number of hot chocolates sold decreases. And then it actually, strangely, it starts to increase again. I'm not quite sure why that would happen. Normally people like hot chocolates when it's cold, don't they? The number of ice creams, as the temperature increases, seems to be increasing, and that makes sense because people don't generally like to eat ice cream when it's really cold, because ice cream is cold. And so when it's really hot, it's a nice treat, isn't it, to cool us down. So let's look at the questions now. We've got the greatest number of hot chocolates were sold when the temperature was, and then we've got a blank. So we need to look at the greatest number of hot chocolates and what temperature that was. So here is the greatest number of hot chocolates. I know that because we've got the item number along the y-axis, and this is the highest point. This one is quite high as well, but not quite as high. So the temperature, I read down to the x-axis, was 5 degrees. Okay, the number of hot chocolates and ice creams sold was the same when the temperature was something. So how will you know when things are the same? Well, it's when the lines meet, isn't it? Because if I look at the ice cream line, I can see that the line increases here, ascends, and it crosses over with the hot chocolate line at this point. And so that means that at this point, both of those were just slightly below 20. So just under 20 were sold, 20 ice creams and hot chocolates. Now, this temperature is going to be a little bit trickier to read. We're going to have to estimate it because it doesn't actually meet one of the numbers on the x-axis. Remember that I have to come straight down vertically. So we can use our estimating skills. We've done that before. The scale is counting up in 5s, and it's between 15 and 20. So I would say that's about 17 degrees. 16 would be about there, 17, 18, 19, 20, about there, okay? What is the difference in the number of ice creams and hot chocolates sold when the temperature was 10 degrees C? So let's have a little look at 10 degrees C. Let's look at the number of ice creams sold. I think that was about 10. Yeah, if I read across to the y-axis, it's 10. And the hot chocolates is at 30. So the difference between 10 and 30, that's a nice easy one because it's multiples of 10. I know that there's 20 between 10 and 30, so that's our difference. Okay, super. So now you've got some independent practice. So you've got a new table to look at, still comparing different pieces of information. And then after that, there is a deeper thinking challenge, and you've got 2 different scenarios to look at there. And remember that the answers are at the end. Hopefully I haven't made any mistakes, but if I have, please let me know. And remember not to skip ahead. Okay, thank you for listening, and I will see you next week for more maths. Okay, bye.